Well, hi and welcome to video 8 and our final video on anti-differentiation. And in this video we're going to look at some more complex cases. After this video there is more anti-differentiation, but they'll be in other various different subtopics, and so the series will also be shorter. So some more complex cases. For this section, a comprehensive knowledge of the results from a range of differentiations will be important, or at least the ability to apply those differentiations, so keep that in mind. So first of all, an important result. If you derive log of a function, so here's my example in purple, log of x squared plus 1, you get 1 over x squared plus 1 times the derivative of x squared plus 1, and that gives you 2x over x squared plus 1. If you derive log of a function, what you get is 1 over that function times by the derivative of that function. We don't obviously know much about it at the moment, so we can write this down as f dash of x over f of x. So an important thing to note here is that this is something to keep an eye out for. And it looks a bit like this in practice. Okay, and I'll show you some more examples in a minute. We'll just make them up and I'll show you what they look like. If you get a question in the exam and it looks quite complex, there is a chance it's this result. So if it's a fraction, or if it could be written as a fraction, ask yourself this question. Is the numerator actually just some variation of the derivative of the denominator? And if it is, it's probably actually a natural log result. In most cases, you'll be asked to first derive something and therefore evaluate the integral, and that's great. But there is a chance that you might not be asked that. You might just be asked to evaluate an integral, and you'll have to work out that this is the situation that exists. So another example of that would be something like if the denominator was sine of x, well, then the derivative of sine x is cos x, and so if you had something like this, that follows this rule. And so if we integrated cos x over sine x dx, well, that would actually just be the natural log of sine x plus c. Because then when you derive that, you get the sine x on the bottom, you get the derivative of sine x on top. So there's going to be plenty of examples that look like this. Let's look at some examples. Example 12. Determine the integral of 2x over x squared plus 1 plus 7 with respect to x. So this is taking that next step where you aren't given a by first deriving. But I hope that you can see here that there's a chance this follows the function on the bottom, derivative of the function on the top. There's a chance that if I derive the natural log of x squared plus, not 7, but 1, then this will come out to be 1 over x squared plus 1 times by the derivative of the inside function, which is x squared plus 1, and that will be equal to 2x over x squared plus 1. So, and that's come from this result as well. So now that I know that the integral will just be this thing. So the integral of that with respect to x is equal to the natural log of x squared plus 1. Of course, I've still got that plus 7. That becomes plus 7x, and I get a plus c. And there's my integral. But we did do the derivative first up here, so that's probably going to be part of a question. And here's our general rule. Now let's have a look at a complex familiar question. So these questions generally fall into the complex familiar category. And that is differentiate log sine 3x and hence determine the integral of cos 3x over sine 3x with respect to x. So let's do part 1 first of all over here. And part 1 is to differentiate d dx of the natural log of sine 3x. And so when I differentiate that, I get 1 over sine 3x times by the derivative of sine 3x, which is cos 3x, times by the derivative of the function inside the function that's inside log, so times by the derivative of 3x, which is 3. So I get this. 3 cos 3x over sine 3x is equal to the derivative of that initial function. And so therefore, the integral of 3 cos 3x over sine 3x with respect to x is equal to the natural log of sine 3x. That's the corollary, so I've just rotated this back into an integration type question because I derived this to get that, and therefore if I integrate this, I get that. And so I've written that down. And that's really important because the actual question is asking me to integrate this, which looks a lot like this, except for this pesky little 3 here. So how do I deal with that 3? Well, what I could do is I could make this look exactly, so this one here look exactly like that by dividing 3 by 3. So that will give me, in purple, therefore the integral of cos 3x over sine 3x dx is equal to a third of log sine 3x. And so I get, well, basically I've just solved the problem. So this is equal to a third of log sine 3x. The hardest thing really in these questions, particularly if you're given a statement like this, the hardest thing that's not based on previous skills is dealing with constants out the front here. That's usually the thing that people get caught up on the most. So just be careful with those constants. This is a really good approach, but we'll see some others as well. So this is the final bit of the anti-differentiation exercises, 9F. Hopefully you can have a go at some of those. Make sure that you ask questions and that you're on top of this stuff before we move forward. All the best.